In the previous part, we have introduced the convection. We will move forward now on. So I have gave the introduction about the convection and different types of convection like free convection and forced convection, and different flow situations like external flow and internal flow. So the governing equation of the convection is the Newton's law of cooling, which states that convective rate of heat transfer is directly proportional to the temperature difference and surface area. Right? Like in conduction, the governing equation was the Fourier's law of heat conduction. In convection, the governing equation is Newton's law of cooling. So we are going to introduce this here. It's stated that convective rate of heat transfer will be proportional to the surface area which is in contact with the fluid and the temperature difference between the fluid and the solid surface. Right? H will be in meters square. The temperature difference can be surface and the fluid reference temperature. Okay. And H is nothing but H is the important property in convection heat transfer, which is nothing but the heat transfer coefficient between the solid surface and surrounding fluid. All right. In convection heat transfer, H is known as the strength of convection. Alright. It means higher the value of H, higher will be the convection. Alright. Convection is a very complex property. It is dependent on many things. So let me write on which aspects they generally depend. It depends generally on flow velocity. Means higher the fluid velocity, higher will be the convection. And properties of the fluid, thermophysical properties, of course, like thermoconductivity, density, specific heat, viscosity, etc. And type of flow which is occurring, like if it is a laminar or turbulent. Alright. Then the quality of surface, like surface is rough or smooth. We know that rough surfaces have higher heat transfer coefficient because they will induce eddies into the flow, which will enhance mixing and which will enhance the heat transfer rate from the surface. Next is geometry of the surface. Is it flat plate or the confined tube, right, or flow over a surface or sphere like that, and also the position of surface. The flat plate is horizontal or vertical or inclined, depends on it. H is a experimentally determined coefficient generally, and one thing to note that H is not a property of a fluid. The main aim of this studying this convection heat transfer is to determine this value of heat transfer coefficient, and in general the heat transfer coefficient for the phase change processes are the highest. For boiling or condensation is higher than the forced convection. Forced convection in which fluid is having higher velocity as compared to free convection, because fluid motion is generated by density differences which are very small as compared to the fluid motion generated by the pump and all. So forced convection always have higher heat transfer coefficients than the free convection. Forced convection in liquids, and also if forced convection is occurring in liquid as well as in gases, the liquid will be having higher heat transfer coefficients. Then the heat transfer coefficient of free convection, if it is occurring in liquids, the heat transfer coefficient for free convection if it is occurring in gases. All right. One more thing to note is that heat transfer coefficient generally varies with location. Let's say if it is flat plate and if fluid is moving from here to here, and let's call it x equal to 0, x equal to L, that is the trailing edge, that is the leading edge of the flat plate. So heat transfer coefficient will have the profile like this. We will see in the later why it is like this. So to have one value over this whole surface, over this whole length, which will demonstrate the same heat transfer as this locally varying heat transfer coefficient, we have to have some average value over the surface, right? So Hx, this is local heat transfer coefficient, let's say it is HTC, and this is area averaged or length average heat transfer coefficient over the whole surface. Average heat transfer coefficient. Right. So from the next we will start the forced convection in external flows. Thank you.